Hello everybody, a very good afternoon to you and a warm welcome to a short topic on biology. Okay, so basically I'll be talking on chapter number 5th of CET textbook and chapter number 6 of NCERT textbook, that is evolution. So I selected this topic because it's a very interesting topic and easy as well. Okay, so let's get started without wasting any time, and we'll see to it that this chapter is covered uh, according to the state board also and according to NEET also. So this would be a beneficial chapter for both the students, okay, CET as well as NEET. So nothing to worry, we'll go line to line, we'll go very slowly, okay, and let's see how interesting it goes. Okay, now this chapter evolution is talking about, or it's dealing about basically evolution of life forms or a biological life on planet Earth. Okay, so let's start from scratch. Okay, what is evolution? So we all know, we use this term, okay, we use it in our daily life also, in day-to-day life also, evolved, right? So what does this term evolution mean? Evolution basically means a change. Okay, so any kind of change could be called as evolution. Say there is lot of uh, tremendous evolution in, say, the mobile world. Okay, you have smartphones, you have iPads, right? So this has been evolving. Okay, this science of mobile or technology has been evolving. So any kind of evolution is not just a one day change. Okay, it's very simple. Say computers also, you have super smart computers. Okay, but the earlier computers were very simple, they were desktops, right? Now you have laptops. So this change from desktop to laptop is not a sudden change, it's not a one day change, it's a slow and a gradual change. Okay, so basically evolution is a very slow change, it's a gradual change. You know that phrase, okay, in English, that Rome was not built in a day, right? What it means simply that you have to have uh, make an effort. Okay, or success does not come as a windfall, it comes by burning the midnight oil. So any kind of success or any kind of change uh, is slow and it's gradual. So evolution, this chapter deals with evolution of life forms. How was the earlier life on planet Earth? We know that the living organisms can be classified into plants, animals, and microorganisms. Okay, broadly we can classify into these three life forms. But how was the first life form, or how could you say that how was the first cell formed on the planet Earth? So to study this evolution, we'll have to first correlate this evolution of life forms with the evolution of planet Earth, and you'll have to correlate the evolution of planet Earth with the evolution of the solar system. I hope you're getting what I mean to say is, okay, everything is correlated, right? Because all living organisms are habitating or inhabiting the planet Earth. So we must know how is the Earth. Okay, basically we are governed by the features of the Earth, or the climate of the Earth, or the atmosphere of the Earth. So we'll have to understand little bit of evolution of the Earth as well, little bit of evolution of the solar system, and then evolution of our star sun, then how our star sun was evolved in our galaxy Milky Way. Okay, and so on, or rather, in short, I can put it in this terms, that how was the universe originated. Okay, so evolution, if you study, is a kind of history. We all have been studying history, right? From our schoolings we have been studying history, and I guess just like me, you also must have found it very boring, right? But this evolution history is very interesting because it is dealing with the origin of the universe. Okay, we know it's bit of astrophysics, and it's of astronomy and cosmology, so it's all very interesting, and I think you'll all find this chapter, or rather this talk, very interesting today. So before going on to deal with the evolution of living forms or living organisms on planet Earth, we'll see how the planet Earth was evolved, or rather how the universe was born. Okay, so this is a little bit of physics and astronomy, but it's an interesting story. Okay, so how was the universe born? You know what is a universe? Okay, universe basically consists of millions and say billions of galaxies. Now million is 10 raised to 6 and billion is 10 raised to 9. You all know that. Okay, so how were these galaxies formed? Were they formed all of a sudden? No. Okay, so there are very theories being put up for the evolution of the universe. So let's not deal with all the astronomical theories, but some two famous theories we'll study, which has been put in your textbook. Okay, the word has been put, and one is that Big Bang theory. Okay, you all must be knowing this. Okay, and but before Big Bang there was a theory called as steady state theory. You know, a renowned scientist of India, Dr. Jayant Narlikar. Okay, so Narayakar sir uh, uh, is the head of Ayuka in Pune. Ayuka is the full form of Ayuka is Inter University Center for Astronomy and Astrophysics, and it's in Pune. So in Pune University. So anytime if you happen to visit Pune University, do take a visit to Ayuka. Okay, so steady state. So Dr. Jayant Narlikar and another scientist, Dr. Fred Hoyle, these two were in favor of a theory called as steady state theory. Now, what does this theory says? That the universe was not born. Okay, there was no origin for the universe. The galaxies have been there for uh, thousands and millions and billions of years. There was no origin, there is no death for the universe. The galaxies existed, they are still there, and they will continue to be there in the universe. This is a simple steady state theory. But to contradict this, you have to have some evidence. If you put some theory, you have to have some evidence also behind that theory, then only that theory is accepted. So steady state theory is no more accepted. The second theory is the Big Bang theory, which your textbook is also mentioning. So we'll see about this Big Bang theory. Big Bang theory says that there was a big explosion. How was this huge universe born? We have say 20 billion, 25 billion galaxies in our universe. I told you earlier that million is 10 raised to 6 and billion is 10 raised to 9. So we have 25 into approximate. Okay, it's an approximate figure. Nobody's it's not possible to count each and every star in the galaxy and so many galaxies in the universe. It's all a physical mathematical estimate. So there are about 20 to 25 billion galaxies in our universe, and the age of our universe is 20 billion years. Okay, so how was this universe born? It was born from a big bang. Bang, B-A-N-G, bang meaning an explosion. Okay, so from that explosion these all galaxies have evolved. So this is about the evolution of the universe. Now before Big Bang occurred, now nobody knows, the universe itself has been born from a Big Bang. So what was there before Big Bang? Was there any space around it? Now it's a little bit absurd concept, it is a little bit hypothetical concept, and it's because you cannot go before time. टाइम का इवोल्यूशन कैसे हुआ? इट्स फ्रॉम द बिग बैंग. जैसे एक्सप्लोजन हुआ उस वक्त से हम टाइम की जैसे गणना शुरू किया हमने, राइट? वी स्टार्टेड मेजरिंग टाइम फ्रॉम द बिग बैंग ऑनवर्ड्स. ओके, एंड द मैटर फ्रॉम द एक्सप्लोजन स्टार्टेड स्प्रेडिंग थ्रू आउट. okay, whenever there is explosion, say for example a nuclear bomb. So if you have an explosion of a nuclear bomb, what happens is the energy in that atom bomb or hydrogen bomb or nuclear bomb, it's liberated out, okay, it's given out in the space around it, okay. So the universe was also born from such kind of explosion, and the matter in that explosion started spreading throughout, okay. And as the matter started spreading throughout, this is how the space was originated. So the concept of Dr. Stephen Hawking's, that is time and space, you know that Dr. Stephen Hawking was a very renowned scientist, and he was called as the second Einstein of the millennium, and he just recently passed away. So Dr. Stephen Hawking has written thousands of books. One of his book is very famous, that is From Big Bang to Black Holes, okay. And in that, the second chapter deals with time and space. So I'm not going into astronomy, but though I'm a microbiology student, I also like astronomy, okay. So Big Bang, so Stephen Hawking has given the concept of time and space, and he says that this time and space has also originated from Big Bang onwards. Now what is hypothetical is that, did the time exist before Big Bang? Did the space exist before Big Bang? It might have existed, okay. Time must have been there before Big Bang. Even space must have been there around before that explosion, but we don't know, because we don't it says that all the physical laws broke when the Big Bang occurred, okay. म्हणजे फिजिक्सचे जेवढे कुठले लॉज आहेत ते कुठलेच लॉ आपण अप्लाय करू शकत नाही बिग बँगला, राईट. सो दॅट इज व्हॉट इट मीन्स, दॅट ऑल द फिजिकल लॉज और द फिजिक्स लॉज were broken during before Big Bang. So you cannot estimate what was there before Big Bang occurred. But in simple terms, I would say that universe took place from the Big Bang, okay, from this explosion. Now it's whenever there are two kinds of reactions in chemistry, that is fission reactions and fusion reaction. Fusion meaning to fuse, to join, and fission is opposite, that is you break, okay. So when you break anything, the energy is liberated, and to join something, energy is required, right. So when the explosion occurred, whatever the energy was there in that matter, it all started getting liberated, okay. It all started getting dissipated around, okay, in the surrounding. So this energy was given out in several dimensions, okay, and slowly that matter started cooling down. Now you know that a firecracker, when you burn a firecracker in Diwali, or say a nuclear bomb, when it gets exploded, it liberates lots of energy, lot of heat energy and lot of light energy, okay. So it's basically a blast, okay. So this tremendous blast dissipated lot of energy around itself, and that is how the matter started cooling. Now if you dump something in a very small space, okay, if you try to put lot of things in a bag, okay, or say some container, what will happen is that the temperature of that container will increase, because the temperature as well as the pressure will increase, because the space is limited. So if you try to dump something in a limited space, it will result in rise in temperature and pressure, okay. So under such high temperature and pressure, the container is likely to explode. The same thing happened during the origin of the universe, okay. All that matter of the universe was condensed into a small tiny pinpoint. Imagine how it could be. Now you have 20 billion galaxies, 20 meaning 20 into 10 raised to 9 galaxies, and each galaxy has got about say 100 million stars at least. Say our galaxy Milky Way has got 100 million stars in it. So imagine 100 million stars in one galaxy, then 100 million stars in every galaxies, and like that you have 20 billion galaxies. So this is how this is the amount of matter in our universe. So all this matter during Big Bang was condensed in a small pinpoint area. So it's but obvious that if you have such huge matter condensed into a small tiny pinpoint, it is going to explode because of high temperature and pressure, as I gave you the example of the container. So that same thing happened, that during the occurrence of Big Bang, this tiny pinpoint had got huge matter of the universe, and it was very unstable because there was it had no space to cool down. So it finally exploded, and the matter was thrown out in all the dimensions, and this is how the matter went on cooling and the space was originated. So the definition of the Big Bang is given as origin of space at the beginning of time. Okay, so let's not go into that detail, that's not of our concern, because we are biologists and we are dealing with this origin of the universe from the point of view of origin of life on planet Earth. So I hope you have understood that how the universe was born. Okay, so it's said that it was all energy, there was no matter, but something came out from this explosion, and slowly uh, the matter got cooled down. Okay, and you know the Einstein's famous equation, E is equal to mc square, that is energy and mass can be they are interconvertible. Okay, and you have c as the speed of light. Okay, so this energy got converted into matter slowly, and as this matter took its space in various dimensions and it started cooling, as it went away from each other, it started cooling. Okay, and because of this cooling, condensation occurred, and you know, like how we have on planet Earth, you have formation of clouds and then the rain starts pouring in. Similarly, during the formation of the universe, during the formation of galaxies also, these molecular clouds were formed. Okay, these clouds are different from the rainy clouds. In rainy clouds you have the water droplets falling down. Okay, but from this molecular clouds you have the gases. Okay, so this molecular because of the origin of the universe, because of the Big Bang, the matter was released and this matter started cooling down. Okay, and due to this cooling and condensation, it gave rise to formation of clouds, but these clouds were called as molecular clouds. Okay, these are not the rainy clouds. These clouds contain basically gases in it and sort of dust. Okay, so this dust is different from the normal dust on the planet Earth. It's called the stellar dust. Okay, the dust in the stars is called as stellar dust. So these molecular clouds contained various gases and dust. It basically was a mixture of gas and a dust. So what kind of gas was present earlier during the origin of the universe? It was hydrogen basically. Okay, hydrogen and helium is the abundant gas in the universe. All the stars and the galaxies are say 90 to 95% hydrogen basically, and rest all is helium, carbon, neon, silicon, all other gases are present. Okay, so let's not go into that detail, but these gases condensed, and due to condensation and of course due to gravity force, what happened is it led to the formation of stars. Okay, I hope you're getting that. We started with Big Bang, we started with a pinpoint. Okay, and that pinpoint was under high temperature and high pressure. Okay, and under such unstable condition, that pinpoint ball exploded. Okay, which we call as Big Bang. The matter from the Big Bang started dissipating into the surrounding space and surrounding dimensions, and it started cooling. Because of cooling and condensation, molecular clouds were formed, and from these clouds, you know that clouds float by. Okay, in the sky you see the clouds moving. Okay, because they are lighter. So same way, these molecular clouds started gaining momentum, they started gaining rotation. Okay, around an imaginary axis. So because of that momentum, because of that rotation, what happened was the energy or the matter in that clouds was thrown out. Okay, it was thrown out. Like you have, say I take a small string and I tie a stone to that one end of the string, and I rotate that string with my hand. Okay, when I rotate that string, what happens is, at a certain, and if I don't tie that stone very tightly, what will happen? Initially that stone will be attached to the string, but as I rotate, due to the centrifugal force, a time will come when that stone will uh, be thrown out in a tangent direction, right? So same thing that happened, that all these molecular clouds which were formed, they started gaining momentum, and due to their rotational motion, the matter in the cloud was thrown out in the form of stars. Okay, and this is how it led to the formation of stars in the galaxy, in the form of galaxy. So each molecular cloud got converted into a galaxy, and this galaxy contained stars and dust also. Interstellar dust, the dust between stars is called as interstellar dust, right? So I hope you have understood that how the universe was born, how the molecular clouds were condensed, formed, and how the molecular clouds got rotation, momentum, and because of that momentum, it led to the formation of stars or galaxies, you can say. So in the same way, our Milky Way galaxy was formed. So this is one theory about formation of galaxies. Now let us come on to from galaxies to solar system, from solar system to Earth, that is a planet. Okay, how this was evolved or how this was formed. Now basically any star has got a nuclear reaction in the core, in the center. Core meaning the center. So the center of the star has got thermonuclear reactions going on and on and on, and that keeps the star burning and throwing light. Okay, we have sun. Okay, sun is our star. Okay, every star can be called as a sun. Okay, so our sun is also a star basically, and the same thermonuclear reactions are going on in the center of the sun. Now what kind of thermonuclear reactions? I told you that hydrogen is the abundant element in the universe. So when 4 hydrogen atoms combine, okay, 4 protons rather, hydrogen I would say 4 protons, 4 H11. I hope you know what is H11. When you put 1 in the above, that is the mass number. When I put 1 below the abbreviation, that is the atomic number, right? So when I combine 4 when 4 protons, these 4 protons get converted into 2 helium atoms, right? So 4 protons, when they combine or fuse together, they form 2 helium atoms. Electromagnetic radiation is given out, and plus some particles called as neutrinos are given out. So basically this is how the star works. Okay, this is a small chemical reaction, that how light is emitted or how the electromagnetic radiation is emitted from the star sun. So as long as there is hydrogen present in the star will keep burning, and it will start giving light energy, okay, in the form of radiation, electromagnetic radiation. So let's not go into more of astronomy, because I just like astronomy, but we have to stick to our textbook. But just one thing that it just came to my mind, it stuck. Yes. So what I wanted to say is that the life, say all stars do not have solar systems, and even if they do have solar systems or planets around them, there is not a possibility of life on every planet. Just let us take the example of our solar system itself, right? So earlier when I was in school, we had 9 planets in our textbooks, okay, starting with Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Pluto was included in the solar system, but now in the textbooks they are revised according to the study and according to inventions. The textbooks get revised. Okay, so we have 8 planets in the solar system. So it's not possible that every star will have a solar system, and if it does have, every planet in that solar system will have life. Now why is it so? Okay, so we are very fortunate. Our star sun is also very fortunate to be at such a position in the Milky Way galaxy that life is possible. Had it been that our star sun was very close in the galaxy, it was in the center, then life would have not been possible. Because you know what, in the center of the galaxies there is lot of energy. There is lot of energy, heat energy and light energy, and under such conditions life is not possible, because it's a very hot gaseous star. Stars, you know, they are very hot, right? So it's not possible. So the position of a star in the galaxy is also very important. You have to have an exact a favorable position in the galaxy. So we are very fortunate, rather our star is very fortunate that it is at such a distance from the center of the galaxy that formation of solar system is possible. Secondly, now this is about our star position of our star sun in the galaxy. Secondly, the position of the planet in the solar system is also very important. Now our planet Earth is at such a distance from the sun that it's just appropriate for the formation. The conditions are appropriate for the formation of life on planet Earth. Okay, because the sunlight coming from the sunlight basically is not just visible light. Okay, the light coming from the sun is not just the visible light. You have many other emissions coming from the star. You have a long wave radiations called as gamma radiations. Okay, you have radio waves also coming. You also have some other cosmic rays coming from the other stars in the galaxies. Okay, you have ultraviolet radiations, which you have X-rays coming from the sun. So all these radiations are coming and they are bombarding the planet Earth. But fortunately we have an ozone protective layer. You all know that. And this protective atmosphere or a layer is like a jacket. It's a protective jacket which our planet Earth has worn, and so we get protected from this ultraviolet radiations and other cosmic radiations, and so because of that life is possible on planet Earth. So the distance of the planet Earth from the sun is also very important. I hope you're getting it. Okay, the distance should not be very far like Pluto, because then अगर sunlight नहीं पहुँचती है वहाँ पे तो heat कैसे मिलेगी, right? तो you require energy for the metabolism. A cell requires a sufficient amount of heat energy also. So like how vitamin D is created in our body because of the sunlight. So our position, rather a planet's position, should be such that it's not too far away from the sun and it's also not too close from the sun, just like Mercury. Okay, Mercury is a very hot planet because it's very close to sun. So life is not possible at extreme positions, not too near and not too far. So we are at a habitable zone, you can say, from the from the sun. Okay, so these are the two conditions for the formation of life on any kind of around any kind of star or solar system. The position of the star also in the galaxy, and the position of the planet also around that solar system. So I hope you have understood these two things. Okay. So this is about the origin of the universe, then how the molecular clouds were formed, then how the galaxies were formed from these molecular clouds, and I told you how a star works. Basically it's a thermonuclear reactions. You have protons combining, joining to form a helium atom. Same way this helium will burn. Okay, helium will burn into some stable element. So you know the periodic table, Mendeleev's periodic table, right? So how many elements are there in periodic table? You all will tell me in the next lecture. Okay, so there are still some vacant places kept in the periodic table, because those elements are yet to be discovered, right? So rest all elements have been discovered. So basically the composition of the life forms on planet Earth is somewhat like the composition of the planet itself, Earth. and the composition of the planet Earth is like the composition of the star Sun. Like star has got hydrogen, even we have carbon, hydrogen, oxygen, nitrogen in our body or in our cell, right? So it's very important to understand the origin of the universe, the origin of the star, the origin of the solar system, the origin of our planet Earth, the conditions on the planet Earth, all this, okay, and how the gradual change occurred, and how the present day humans are there or other life forms are there, okay. So this all is very, and though it's a history, it's an evolutionary history, but it's a very interesting history, okay. It's not the history which we studied at 8th, 9th, 10th, and that boring history which we had to mug up, okay. So that's a very interesting history which we can just, if you understand, it's easy to memorize, okay. So this is how the universe was born, okay. And the planets, now there are many theories, as I told you, like there are theories for origin of the universe, there are also theories for the origin of planet Earth, okay. अर्थ के फॉर्मेशन के भी अलग अलग थियोरीज है, एंड देर आर कॉन्ट्राडिक्टरीज, ऑलवेज देर आर कॉन्ट्राडिक्शंस टू एवरी थियोरी, okay. But the theory which is more accepted is which is based on evidence. You have to have a proof for it, okay. So let's not go into that contradictions now. What is the estimate, the time scale, what is the time scale of the evolution of the earth, okay, how, or rather the formation of the earth from in the solar system. Now if you go back to carbon dating, I hope you all know what is carbon dating, we've studied in school, okay, how the carbon dating is done. You have sedimentary rocks, you have layers of rocks, and based on the composition of the rocks you can the carbon present in it, okay, the isotope of carbon C12 and C14. So according to that you do the dating, okay. The oldest rock will have the age is calculated, okay. If you have the remnants of plants and say dinosaurs, okay, when they existed, and they must have, okay, when the dinosaurs died or when the plants they died, okay, they were buried into the sedimentary rocks, okay. So and then you have landslides, and you have volcanoes, and you have earthquakes, okay. So it goes on depositing a layer on a layer on a layer on a layer, okay. So as you go back and you do this carbon dating, you come to know the age of that rock, okay. And from that if you get some fossils or micro fossils in that rock, you can easily estimate the age of that plant also, when it existed, in which era, okay, or the animal when it existed. So this is how with carbon dating you can find out the age of some old species, okay, plant species, microbial species, or animal species. So earth basically was formed about 4.5 billion years ago, okay. Now of course I told you that from a star the planets were formed. So earth was also, since our earth is since our star is very hot, obviously the planet which is formed from the star is to be hot also, okay. In the earlier stages the planet earth was also in a molten condition, it was not a solid planet, okay. It was very hot, gaseous only. It contained some gases, like of course hydrogen was there, because star has got hydrogen, so obviously our earth's earlier atmosphere also had hydrogen. Then methane was there, okay, ammonia was there, NH3CH4 H2 was there, but there was no free molecular oxygen, okay. O2 was not there, right. So you all know that for survival of life, for any life forms, you require oxygen, right. So oxygen was absent, it was a reducing atmosphere at the earlier times. Earth was in a molten condition because it was very hot, it did not have any shape. You know, a molten material does not have any shape, but when the molten material solidifies, it gets some shape of a rock. जैसे अगर कोई वोल्केनो होता है, उसमें से जो लावा the lava which comes out, which flows out from the volcano, it's in a molten state, but as it goes on cooling down, condensing, it takes the form of a rock, okay, igneous rock, or other kind of rocks. So same way earth was in a molten state, it was not a planet, it did not have any shape, okay. But slowly as the time passed, earth started cooling down. Okay, earth started cooling down, and there was a lot of since it was hot, it was lot of thundering was happening. Okay, lot of lightning was taking place. Okay, lot of radiations were coming from the sun. Okay, and earth did not have any protective atmosphere. Okay, so there was always a continuous bombardment of, say, some chunks or stones from the space. Okay, now also at present moment you have thousands of stones or chunks of rocks coming from space and entering into our earth's atmosphere. But uh, we are fortunate because we have ozone protection, and so these all stones or rocks, they get burnt into the atmosphere itself, that we call as meteor or shooting star, which we can see at night. Okay, but unfortunately, if some stone happen, which is a huge stone, and if it happens to enter the penetrate through the earth's atmosphere with high velocity, and if it bombards on the surface of the earth, then it can lead to a crater. Okay, so that is called as meteorite. Okay, when it gets burned into the atmosphere, it's called meteor, shooting star. But if it falls on the planet earth, it's called as a meteorite. So because of meteorite fall, you have craters. Okay, on planet earth there are many craters. Okay, the few of the famous craters is Arizona crater, you all know, right? And in India or in Maharashtra, we have in Buldhana district, we have Lonar Lake. Okay, so Lonar Lake is also because of it is formed because of the meteorite fall. So earth got its so earlier atmosphere was very earth being very hot, it was more of gaseous rather than solid, and the solar radiations were also coming, and it was penetrating the earth. UV radiations were also falling, all the stones, and there was bombardment of stones. Okay, space stones. And so it was all a chaos, it was all chaos. It was not, it was a reducing atmosphere, there was no free oxygen. So it was all toxic gases existed in the earth's atmosphere. You had methane, you had ammonia. Okay, so the conditions were not favorable for the formation of life. But slowly as the earth cooled down, okay, it led to the formation of clouds. Okay, so like I told you how the molecular clouds were formed at the beginning of the universe, in the similar manner these are the now rainy clouds, because we had hydrogen in the atmosphere. So obviously it led to the condensation. You had water vapor, but we did not had liquid water. Okay, earth's earlier atmosphere had H2O, but in the form of steam or in the form of vapor. It was not in the liquid form. So these gases, they evaporated from the surface of the planet earth, and they condensed and they formed clouds, and it led to the formation of rain. So this is how the rain started falling on planet earth. And these were not just the simple rainy season which came for 3-4 months. Okay, these rains continued for thousands and millions of years. If I'm not wrong, these they are called as torrential rains. Torrential rains meaning continuously it was raining and raining on the planet of earth, and this, because of this rains, the planet earth started cooling down more fastly. Okay, so this molten planet now got slowly cooling down and getting converted or evolving into a solid planet, and that is how the oceans were formed on the planet earth. So because of the molten lava, rocks were formed first. So earth did not have some proper shape. Okay, you can say it was just like a पापड. You know how पापड कसा दिसतो भाजल्यावर, तशी आपली पृथ्वी होते इनिशियली. ओके, पण नंतर जसे जे खाच खड्डे जसे पाण्याने भरत गेले, बिकॉज ऑफ द रेन्स, टॉरेंशियल रेन्स, the oceans got filled up, and then the earth got a spherical shape. So this is how the earth was formed, and these rains continued for 10 million years. 10 million years there were continuous raining on the planet earth, and because of that you have such vast oceans. Okay, you have Pacific Ocean, you have Indian Ocean, right, Bay of Bengal. So all these oceans were filled up during the origin of the planet earth. Okay, so this is how I think we should stop here. It's a 40 minutes have been over. So after this, this earth was formed. Now after that, slowly we'll see how the life was formed on planet earth after cooling. Now for this process, for cooling of earth, it took how much years? Now earth took 4.5 billion years. Okay, so earth was originated 4.5 billion years. Okay, and after 4.5 billion years, I mean after 500 million years, I hope how you read the time scale. I hope you understand. 4.5 billion years ago, Earth was formed, and after the origin of the Earth, 500 million years after, meaning 4 billion years ago, life was formed. Okay, so 4.5 billion years ago, Earth was formed, and half billion year after, meaning 500 million years later, life was formed. But of course this life was not the proper cell and the proper say prokaryotic cell or a eukaryotic cell. It was just a beginning. Okay, it was a beginning. So at 4 billion years ago also, there was no proper formation of cell. A true cell was formed, say, 2 billion years ago. Okay, so from 4 billion years to 2 billion years, how many billion years it makes? 2 billion years. So for the formation of one true cell or a proper cell, okay, how can you call a proper cell? A cell with a true nucleus, okay, with the metabolic reactions, anabolic and catabolic reaction happening, that is called as a true cell. So formation of true cell took 2 billion years. Imagine how slow the process would have been. So evolution is always a slow process. It's a gradual process and periodic process, and it takes towards it's a progressive process. To be more precise, it's a progressive process. It is always towards the best happening. Okay, so so this is about evolution. Okay, so I think we'll stop here, and I have made it to the best of my ability to make you understand how the Big Bang occurred. Okay, how the universe was born, how the galaxies were born, basically how a star runs or how a star burns, and how the light is liberated, how our earth was originated from star sun, and how were the original or the primordial conditions on the planet earth. We'll study in more detail about the conditions of the earth and the formation of cell in our next sections. Okay, that's all for today, and thank you. Bye.